Hydrocarbons are classified into two, linear and branch. So linear hydrocarbons are hydrocarbons without branches, while branch hydrocarbons are hydrocarbons with branches. Hydrocarbons are further classified into three types. You have alkane, having single bond. You have alkene, which are hydrocarbons with double bond, and alkyne, which are hydrocarbons with triple bonds. Let's get to know how to name them one at a time. So if it's an alkane, you will use the suffix ane. For double bonds, if it's an alkene, use the suffix ene. And if the compound is a triple bonded compound or alkyne, you will use the suffix yne. The second thing that you should remember is to identify how many carbons are there, because the number of carbons identifies the prefixes. So here are the list of prefixes. So if the compound has only one carbon, you will use the prefix meth. For two carbon atoms, the prefix eth. If there are three carbon atoms, butes. If there are four carbon atoms, and so on and so forth. Now, you will follow three steps in naming a hydrocarbon. Step number one is to identify the parent chain or the longest carbon chain. It should be continuous carbon chain, meaning to say you could make a line passing from one carbon to another without breaking the line. The second one is to assign numbers to the carbons only in the parent chain. And the last one is to name the branches. Here is an example. Now, the first thing that you must identify is whether this is an alkane, alkene, or alkyne. Looking at the structure, you see that all the bonds are in a single bond, meaning to say our compound is an alkane. The second one is to identify how many carbon atoms are there. And based on the structure, we only have one carbon atom. Now let's now name the hydrocarbon. Step number one is to identify the parent chain or the longest carbon chain. Since our compound here has only one carbon, meaning to say the entire thing is the parent chain. So now we assign the numbers to the carbons in the parent chain. Since you only have one carbon here, you don't need to assign because one, or without writing any number, that means it is equivalent already to number one. Since this one has only one carbon, this doesn't contain branches. So meaning to say we will only focus on number one, which is to name the parent chain. So our compound has only one carbon, so therefore we will use the prefix meth. And to tell the readers that this is an alkane, we use the suffix ane. Hence the name methane. Our example here has two carbon atoms linked together, which makes the entire molecule the parent chain. If the entire molecule is the parent chain, no need to proceed with step 2 and step number 3. So let's name the compound. Our compound has only single bonds, making it an alkane, so we will use the prefix ane. Now there are two carbon atoms in our compound, we will use the suffix eth. That means to say, since the prefix is eth and the suffix is ane, the compound has a name of ethane. Ethane is a gas used to make plastics, while the previous example, methane, is a natural gas. For our third example, we have three carbon atoms that are linked together. That means we have the parent chain. Since the three are linked together, no need to do step number 2 and step number 3. So let's just simply name the entire molecule. Our entire molecule has only single bonds, so we will use the suffix ane, and there are three carbon atoms present. We will use the prefix prop, hence the name propane. Let's try to name our next example. So step number one is to find again the parent chain. Now, as you can see in our example, there are a lot of carbon atoms. And if we are going to find the longest carbon chain, how do we do that? So just start from any endpoint of a carbon. So you have an endpoint here, an endpoint here, and an endpoint here. So if we are going to start from the left, if you're going to make a line connecting only the carbon atoms, when you reach this point, you have two pathways, either going up or going down. If you are going to move upward, you will end up with this carbon. And as you can see, there are no more carbons linked to this carbon, meaning to say the line stops there. So if you're going to count how many carbon atoms did you pass along the line, you'll have one, two, three carbon atoms. On the other hand, if you are going to go to the left, so passing from this carbon, going to this carbon, to the next carbon, up to the last carbon, you will be able to have one, two, three, four, five, six carbon atoms. That means the longest carbon chain has six carbon atoms in it. So you are done with step number one. For step number two, we are now going to assign the numbers to the carbons in the parent chain. Now, where do we start counting? From the left or from the right? The answer depends on where the branch is located. Now, what is a branch chain? A branch chain is a carbon that doesn't belong to the parent chain. Now, looking at our structure, these carbons along the red lines are part of the carbon chain, while this carbon here is not part of the carbon chain, which makes this carbon part of the parent chain. Now let's go back to the question. Where do we start counting? From the left or from the right of the line? So again, the answer depends on the location of the branch. Now, since the branch is located on the left side, we will start counting on the left. But if in case, for example, this branch is located here towards the right side, we will start counting from the right side. But since our example has a branch near on the left side, we will start counting from the left, and you will assign numbers like this: 1, 2, 3, 4, 5, and 6. Again, according to step number 2, the numbers are only for the carbons in the parent chain, and you will start counting from where the branch is located. To name a branch, you just need to follow three simple steps, which are: step number 1, identify how many carbon atoms are there in the branch. Our branch here has only one carbon atom, therefore we will use the prefix meth. Step number 2, just simply add the suffix YL, which is solemnly used for branches. And then step number 3 is to tell which carbon atom is the branch attached to. Our branch here is attached to carbon number 2 of the parent chain. Just simply write the number 2 here and separate the number and the letter with a dash. So that is step number 3. Now, when you're done naming the branch, just simply go back to step number 1 by naming the parent chain. Our parent chain, which is the carbons along the line, is composed of 6 carbon atoms. So 6 carbon atoms uses the prefix hex, and everything has only single bond. Therefore, this is an alkane. Then just add the suffix ane. Take a look at this next example. So let's identify first the longest carbon chain. If we are going to start from the left, we can have the following option. So passing to the first carbon, going to the next, going to the next. Then when you reach this carbon, you have two options: either go up or go to the right side. Going up will lead you to this carbon that is not connected to any other carbon. But if you go to the right, you will pass this carbon, which is again connected to another carbon. If you are going to use this pathway, you will have a total of 8 carbon atoms. But if you're going to go to the previous direction, which is going up, you will only have 7 carbon atoms. So that means the parent chain is this direction here. Now, let's name the parent chain. The parent chain has a total of 8 carbon atoms. That means we will use the prefix oct. And then since every bond here is single bond, we have the alkane. Therefore, we use the suffix ane. Next is to assign the numbers to the carbons in the parent chain. But the decision making is where to start, which end. The answer depends on the location of the branch. Since the branch here, this carbon atom, is located to the right side, we will start counting from the right. Hence, the number is as follows: 1, 2, 3, 4, 5, 6, 7, and 8. Next one, let's now name the branches, or the branch in this case. Our branch has only one carbon atom, therefore it will use the prefix meth. And to tell that this is a branch, we use the suffix yl. And then we identify to which carbon atom is the branch connected to from the parent chain. Our branch here is connected to carbon 3 of the parent chain. Therefore, we will place the number 3 here and separate them with a dash. Therefore, the name of our compound is 3-methyl octane. Let's have the next example. Let's find the parent chain in our molecule. Starting from this carbon here, we will pass to going to the next carbon and then to the next carbon. If we're going to move down, that's only one carbon, but we have more carbons towards the right side. So let's continue the line. If we're going to reach this point and then move upward, that's only one carbon. We have more carbons towards the right side. If you're going to reach the next carbon, you have two options: either move down or go to the right. Either way, you will still land with one carbon left. So let us just move towards the right side. Next one, we are going to name it. Our parent chain has 6 carbon atoms. So that means we will use the prefix hex, and to indicate that everything is single bonded, ane. Next one, we are now going to assign numbers to our parent chain. Now we have here 3 branches. We have a branch here, here, and here. Now, which of the 3 branches are near to the ends? This branch here is near to the left compared to the branch here, which is towards the right side, because this carbon here, or this branch here, is 2 carbons away from the right side, while this branch here is 3 carbons from the left. So that means this is nearer to the right side. We will start counting from the right. 1, 2, 3, 4, 5, and 6. Okay, next one. We are now going to name the branches. This one, we have 3 branches, and let's name each one of them first. For the first branch, this branch here is named as, since this is attached to carbon number 2, this is 2-methyl. Okay, meth because one carbon only, and it is a branch, so methyl. The next carbon here, which is attached to carbon number 3 of the parent chain, is named as 3-methyl. And the last one is attached to the fourth carbon atom, hence the name 4-methyl. Now, if you notice, all the branches are methyls. So we can just simply combine them and write as follows. So write the numbers first in numerical order. So that those are 2, comma, 3, comma, and then 4. Then separate it with a dash. And then to indicate that there are 3 methyls, we will use the prefix tri. And then just write the word methyl, which makes our molecule named as 2,3,4 trimethylhexane. Now, how do we check if our answer is correct? We can actually do the reverse process, which is like this. So we start backward. So first draw a hexane. So that means 6 carbon atoms, single bonded. 1, 2, 3, 4, 5, and then 6. Number the carbon atoms. We have 1, 2, 3, 4, 5, and 6. So we are done with the hexane. Now we will just need to follow the first name, which is the 2,3,4 trimethyl, which means there are 3 methyl branches. And where are they located? In carbon 2, 3, and 4. So we just need to add a methyl in carbon number 2. So that's a CH3. CH3 is just simply a carbon attached to 3 hydrogen atom. So the condensed form of this is this one, CH3. And then we also have at carbon number 2, so that's CH3 again. And then we have another one at carbon number 4, which is CH3. Then just simply add the remaining hydrogen atoms to complete the stability of each carbon atom. Let's just use a red pen to indicate the hydrogen atoms. Okay, and as you can see, the molecules are the same, only in reverse order. Anyway, they are still the same. So as you can see, in carbon number 1, we have CH3. We have here carbon number 1, C with 3 hydrogen atoms. In carbon number 2, we have 1 hydrogen atom and then a methyl group. So we have carbon number 2, 1 hydrogen, and then a methyl group. In carbon number 3, 1 hydrogen, a methyl group. 1 hydrogen, a methyl group. In carbon number 4, 1 hydrogen and a methyl group. Carbon number 4 here, 1 hydrogen and a methyl group. And then for carbon number 5, 2 hydrogen, that's 2 hydrogen atoms. And then at carbon number 6, we have 3 hydrogen atoms. Indicated here by the lines are 3 hydrogen atoms. So that means our name for this molecule is 2,3,4 trimethylhexane. And again, if you want to check your answer, you may do the reverse process. Now for our last example, for alkanes, identify where is the parent chain in our example. The parent chain in our example is located here, this one. So this chain of carbon here has the longest carbon chain, having 1, 2, 3, 4, 5, 6 carbon atoms. So identify the name of our parent chain. Since it has 6 carbon atoms, we will use the prefix hex and ane for the suffix to indicate that what we have is an alkane. So let us write here the word hexane. The next one is to assign the numbers for the carbons in the parent chain, but decide whether to start on the left or on the right, depending on where the nearest branch is located. The nearest branch between these two branches, let me just encircle the branches that we have. We have a branch here, and we also have a branch here. Now, which branch is near to which side? This branch here is near to the right side since it's just 2 carbons away from the right, while this branch here is located 1, 2, 3 carbons away to the left. So since this is nearer, we will start counting from the right side. 1, 2, 3, 4, 5, and 6. So we are done with step number 2. The last step is to name the branches. Now, what is the name of our branch here? This has one carbon only, so this is attached to carbon number 2, 2-methyl. Now, what about our second branch? As you can see, our branch has 2 carbons in it. Therefore, we will be using the prefix eth attached to carbon number 4. Therefore, it is 4-ethyl. Now, how do we write the branches which are different from one another? The rule is simple. List them alphabetically. So between ethyl and methyl, alphabetically, ethyl comes first. So therefore, write the following: 4-ethyl. Okay, and then follow it up with another branch, which is dash 2-methyl. Now, as you can see, we always separate the number to the letter with a dash. So therefore, what is the complete name of our molecule? The complete name of our molecule is 4-ethyl 2-methylhexane. Write first the parent chain, hexane. 1, 2, 3, 4, 5, and 6. And then you may write the numbers either left or right to left. I will write it in the left side, starting from the left side. 1, 2, 3, 4, 5, and then 6. Since you now have the parent chain, you can now proceed with the branches. So we start with the 4 ethyls. That means there should be an ethyl, a 2-carbon branch located at carbon number 4. So we have 1 carbon here and another carbon. And then you have a methyl in carbon number 2. You can either write upward or downward. So we'll just write it here because there are more space downward. And then just indicate the number of hydrogen atoms needed. So for this carbon, we need to have 3 hydrogen. This one needs 1 hydrogen. This carbon needs 3 hydrogen atoms. This one needs 2. This one just 1. This one needs 2. This one needs 3 hydrogen atoms. This carbon here needs 2 hydrogen atoms. This carbon at the bottom needs 3 hydrogen atoms. Then compare if you got the same result. So again, even though we started here from the left side, but our example here is on the right side, they are just the same. So carbon number 1 has C and then 3 hydrogen. That's this one. And then carbon number 2, a hydrogen with a methyl. So you have a carbon here with a hydrogen and a methyl. And then at carbon number 3, no branch, just 1 hydrogen. This one should have 2 here. Okay? So anyway, so we have a carbon here and then 2 hydrogen atoms. And then follow it up by carbon number 4 with 1 hydrogen and an ethyl. So 1 hydrogen and then ethyl branch. Then carbon number 5. This one has 2 hydrogen atoms, no branch. There you go. And then carbon number 6 will just simply have 3 hydrogen atoms attached to it. Therefore, the name of our molecule is 4-ethyl 2-methylhexane.
Tell me pretty lies, look me in the face. Tell me that you love me,